Hi there, I'm Javier Torres, and in this video I will be presenting my solution to the natural language processing challenge using the IMDB dataset to perform sentiment analysis. I'm excited to share my approach and findings with you, and as a highly accomplished industrial engineer with a master's degree in logistics and supply chain, I have always been passionate about utilizing cutting-edge technologies to solve complex problems. During my academic pursuit, I had the privilege of working with supervised machine learning and specifically regression models. The experience was nothing short of transformative, and I was instantly hooked. To take my passion to the next level, I decided to enroll in a comprehensive machine learning course, which turned out to be a wise decision. This experience expanded my perspective and deepened my desire to keep learning and exploring the limitless possibilities that machine learning presents. Now I'm more driven than ever to integrate my vast knowledge and experience in industrial engineering, logistics, and supply chain management with my passion for machine learning. That's why I'm eager to participate in this program. I'm confident that working alongside other like-minded professionals and being mentored by experienced data scientists and machine learning engineers will provide me with the hands-on experience I need to successfully pursue my PhD. So let's get started the explanation for this project. I first imported all the required libraries, then use save file to read the save file and extract all the files inside this main file. Use speed read CSV to read the CSV, the data set, then print the first 5 rows, then print just one single review. Here I started the cleaning operations or pre-processing actions to remove the HTML tag, this that you see here. I define this function and then apply it, and as you see here, this tag was removed. Then define another function to expand contraction, for example, I'm to I am, and so on, using fix from the contractions library. Then apply this to the function, to the data set, define a new function to remove all punctuation using a string punctuation and also make each word lowercase. Apply this, and as you see now we have no punctuation marks, and also each word is lowercase. Then define another function to remove the stop words. I use here stop words and words English in order to remove words such as the, a, this, and more. Using this data set from the natural language toolkit, apply this, and as you see, I remove words such as by, the, and so on. Now we have a clean tweet, clean review. Here let's tokenize and lemmatization. I use here word tokenize to split the reviews into individual words, as you see here. Then define this function to lemmatize each word to their canonical form. For example, we have here looking, watching. These words were transformed to their canonical form to look and watch. And then just define this function to combine these individual words. And as you can see, we have now the full review. Then rename the data set and create a copy. Here I just started the process to transform these categorical values and text to numerical values, and I first just plot out these two categories, positive and negative. Both have both categories has 25,000 reviews. This is a balanced class. Then just use label encoder to transform positive to 1 and negative to 0. Then here in tokenizer in Keras, I use tokenizer and set the number of 20,000. That means that I will keep just the 20,000 most frequent words, then feed this on the reviews, call the text to sequence to transform this text into a sequence of integers, as you can see here. Then use train test split and set the test size of the 30% of the whole data set. Use this path sequence to transform the sequence and set the max length of 40. That means that we will have a sequence of with a max length of 40 integers. Here with the modeling, I set these parameters: input dimension 20,000, output dimension 50, and input length 40. And the units equal to 1 for the last layer. Here I call the sequential model and then add some layers, an embedded layer using these parameters. Then the long short-term memory layer with 128 units and a dropout rate 0.6. Then two dense layers, two fully connected layers with 32 units, activation function redo, which I'm familiar with, and a dropout 0.6. Then the last layer with 1 unit, activation at sigmoid to get output between 0 and 1. Then compile and fit the model. As you can see here, the model starts with a loss of 57 and drop out to 33, and the accuracy also shows an improvement from 67 to 87, and the validation also improved from 82 to 82, which shows looks good. And here just a classification report to see additional metrics. Precision recall and F1 score. Precision show us that 88% of the reviews were identified as negative and 80% as positive. Recall means that 77% of the reviews were currently labeled as negative and 90% were labeled currently as positive. The F1 score just shows that the model performs fairly well for both categories and a general accuracy of 84%. As a next steps, well, I suggest to train the model a bit more, explain different architecture, explore different or alternative combination of units, dropout rates, optimizer, and so on. Develop some additional cleaning actions and also apply different layers such as various recurrent units, or use different models such as supervector machines or logistic regressions. That was all for this video. I hope you can enjoy this, and let me know if you have any question. Bye for now.